Hey guys, this is Garrett Wong, also known as Ensign Harry Kim from Star Trek Voyager, and you're watching Astronomy Live.
T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop.
Hi folks, welcome to Astronomy Live. Tonight, we're going to be tracking asteroid Apophis. So, Apophis just recently passed its closest point to Earth for this particular apparition. And another noteworthy point of interest and really sad news event to come out of this is just a couple of days ago, one of the co-discoverers of Apophis, Roy Tucker, passed away after a battle with cancer. So that's what I've heard from the Minor Planet mailing list. So sad turn of events there, and probably his most famous discovery was this asteroid. So according to Wikipedia, he had tagged 702 numbered asteroids between 96 and 2010, and also discovered 2 comets. He was quite a prolific discoverer of asteroids, including Apophis, which should now be in the field of view. So let me just check here with the star chart. Guessing it's probably going to be about there. But it'll be easier to see hopefully once the dark frame completes here in 40 seconds. I'm going to fire up some Stellar Drone music. All the music you hear tonight will be from Stellar Drone. Yeah, I was afraid of that. The camera's acting wonky tonight. It's not giving me clean dark frames. So the images are looking kind of grainy. I think this is it right here, actually. It's right in front of me. Right here. I'm going to highlight it with this little box. I believe this is going to be Apophis right here. We'll see if it moves in the next exposure. Seems like the camera's having some issues. It does not play kindly with Windows 10, unfortunately. This old camera does not do well. Whether it's the software or the camera, I'm not sure, but it especially has trouble if other windows pop up while it's running, which isn't happening right now, but I also have a theory that it also has trouble whenever Windows is doing updates in the background, which it might be doing right now. Oh yeah, it definitely moved. So that is Apophis there. I'm not so happy about this noise pattern. I'm going to try and fix it for what it's worth. One second. While I do that, oh, okay, that doesn't work. I thought I'd be able to play a replay of Apophis from the last Deep Space webcast a couple weeks ago, where we also tracked it, but the video doesn't want to come up. Sorry about that. So, we'll just come back to the live images. 1 second. Okay, we'll come back to the live images, and we'll take it up to a 3-minute exposure. Guide star. Okay, so again, Apophis is this streak right here, right above this star. And so when the next exposure comes in, you'll see that the position has changed. The star we're guiding on tonight is 23 Hydrae, which is a magnitude 5.2 double star. It's significantly brighter than most guide stars that I tend to have available, but this was positioned so that if I just offset Apophis slightly in the view, I'd be able to keep this guide star in the view and lock onto it. We're using the AO7 tonight. This is an adaptive optics unit with a tilt-tip mirror system that makes high-speed corrections to keep the guide star perfectly centered and correct for some atmospheric distortion as well. So we're guiding at 16 Hertz right now. It's making 16 corrections per second based on the detected position of the guide star to help compensate for atmospheric turbulence. It's actually a double star, and the separation is only 1.3 arc seconds, which is about 1 pixel in the view. So you might notice that guide star up in the top left here, this little wobbly star here, kind of looks a little elongated. That's probably because it's a double star. According to SkySafari Pro, its separation is 1.3 seconds, arc seconds. However, the secondary is also much dimmer, magnitude 10.8, so I wouldn't be surprised if it's actually not picking up the secondary at all in these rapid exposures, because it's probably too dim to pick that up. But it could be contributing somewhat to an elongated shape of the guide star. It's possible. However, I still think most of that is probably atmosphere that the adaptive optics unit is trying very hard to compensate for. Whoa. What happened there? What? Whoa. Oh, oh no, I've gone and done a terrible thing. I've gone and done a terrible, terrible thing. Okay, oh dear, this is what I get for trying to highlight Apophis. It took a shot where Apophis had been, and it only did a subframe. Yikes. Okay, well, we'll try it again. 3-minute exposure coming up. So, yeah, it only took a picture with a very small subset of pixels of the CCD. Literally where I drew that box around Apophis a moment ago, it turned on subframe exposures and only captured those pixels. Of course, Apophis had moved since I took that picture, so it's no longer in that little box, which is interesting, but not what we were going for. So, I've corrected that. Should be able to get it now. And the ultimate goal here is to collect some data on the position of the asteroid Apophis to be able to solve for the orbit by combining this with the data from the previous webcast a couple weeks ago, and also some data I collected in between about a week ago on itelescope.net. Combining this with other amateur data collected over the years on Apophis, it should be possible to show, based purely on amateur data, that the asteroid is truly not a threat to hit us in 2029. When it was discovered in 2004, there was a significant chance that it would collide with Earth in 2029. And this was obviously cause for concern. This asteroid is fairly significant in size. So, yeah, 370 meters. And yeah, the initial probability of impact was 2.7%, which is quite a bit higher than your typical asteroid discovery. So this was, cause for significant concern. It was quickly ruled out, though, for 2029. However, a possibility remained for 2036. That has since been ruled out, and now the possibilities for impact don't really open up for decades into the future. So, yeah, 2029 ruled out, 2036 ruled out, and the first impact possibility is not until the 2050s into the 2060s, and very, very, very low possibilities there as well. So nothing to worry about in the immediate future, but for a time it was the most threatening asteroid out there. And in 2029 it will make a very close approach by Earth, and be significantly brighter than it is this year. This is the last chance we get to see it close to Earth before 2029. But in that year, it will come close enough, I believe, to even be naked eye visible at that point. Unpaid. Andrew Knoll thinks I'm a Kroll, thinks I'm more than an amateur, more like unpaid, self-trained astronomer, I guess, but that's what amateur means. I do it for the love of it, not because I'm paid. I'm not paid to do this. That's literally what the word is really meant. Some people take it for novice, but that's not really what the intention of that word is. So there we go. Apophis is right here. It's this nice little streak right there in the view. And now it's going to take a 3-minute dark frame, take out these hot pixels, and we'll move on from there, tracking the asteroid for a little while tonight and get some data. So ultimately I'll make a video about this showing the images not only from tonight but from the webcast a couple weeks ago and from some images I collected in between from itelescope.net, and combine all that data with some amateur observations from years ago when it was discovered, and it's made a couple of passes by Earth that have been observed. And so, taking just amateur data alone, it should be possible to solve for the orbit and illustrate that it is truly not a threat for 2029. In other words, you don't have to rely on NASA's word for it, or Roscosmos, or any other national space agency. Amateurs are able to collect enough data on asteroids like this to rule out or verify impact possibilities. In fact, amateurs provide a wealth of data for professionals to use to be able to study these asteroids and determine their true probabilities of impact, or at least refine the probabilities for impact. It seems like the music's getting a little loud there again. Sorry about that. So yeah, any questions about this? Why do people think the R in your name is an N? I don't know. Kroll sounds very sci-fi. I don't know why. It just sounds like a sci-fi species to me. Knoll, I don't know. I've known some Knolls, but never known a Kroll, so I guess that's why I had a slip of the tongue. Sorry, Andrew. Alright, 5 seconds left on this dark frame. Hopefully we get some good results out of this. Having to run the camera a little warm tonight. My desiccant is all bad. It's all bad. I've tried to recharge it with microwaving, and that has not helped. So, alright, that looks good. Yeah, that looks much better. I'm much happier with the noise pattern of this image than the others. So I will live with this. So there we go. Apophis is right there. It's that little streak. And the next exposure, we'll see it move from its previous position. And it should be moving down and to the right in the image. Enjoy. So, just a note, I've just fired up a telescope in New Mexico with itelescope.net to collect some observations simultaneously with my scope here. This will allow me to collect some data on the topocentric parallax, the parallax due to the telescope's difference in position on the face of the Earth, to help nail down the distance a little bit better and refine my amateur orbit determination of this asteroid. While it is possible to figure out the distance from a single position, time is a very important variable in that. The longer you can monitor the asteroid, the better you can nail down the distance as a variable. Of course, adding data from another telescope somewhere else in the world simultaneously helps refine that variable as well. So that's what I'm doing right now. So I just fired up T5 on the iTelescope network, and it's starting to collect observations of Apophis at the same time. So I'm going to go check those real quick and make sure they're coming in well. And that will help with the ultimate goal of doing an amateur determination of the asteroid and looking at its encounter with Earth for 2029. So I just checked the first image in from the telescope in New Mexico. I see what I think is Apophis, but it's hard to tell. It's a wider field of view, I think, and certainly shows a lot more stars. So it's a pretty dense star field. It's hard to find my bearings around there, but I did see a streak near the middle, and I'm pretty sure that's Apophis. I'll have final confirmation, of course, once I get all the images and I can look at the asteroid in motion, like what you're seeing here. Looks like everything's running smooth, which is nice. Oh, was I able to use the same guide star in New Mexico? I don't think so. The camera's probably oriented differently there, I think. And it doesn't matter. It auto selects the guide star for you. The system is sort of set it and forget it. You just tell it the coordinates you want it to go to, an image, for how long, with what filters, etc. Guide star is handled automatically. If it has trouble finding a guide star, it'll shift things around a bit. But for that scope, I think it does rely on a guide star. Some of the scopes are so high quality, the mounts are so incredible that they don't need guide stars. They just run unguided and they get perfect images. You know when you're doing that you have a very expensive mount. But for this one, I think it's a Paramount, and I think it does use a guide star. But it's automatically determined and selected and locked onto. For my scope, though, definitely need a guide star, and the adaptive optics unit definitely adds some edge to it. It allows the scope to punch above its weight, because even with a guide star, this scope has significant drive backlash. And that would be an issue, except for the fact that the adaptive optics unit makes it a moot point, because it's not relying on the drive as the primary guidance method. It keeps it within the bounds of this tilt-tip mirror system. You can see X tilt, Y tilt up here, these percentages, how close it's getting to the limits of travel on one side or another of the X and Y axis. But it keeps it within those bounds using the telescope's motors. But beyond that, most of the corrections are made with the mirror system itself. So even if it takes it a few seconds for the drives to kick in due to drive backlash, it's not an issue, as long as it keeps it within the bounds of the tilt-tip mirror. Is my audio cutting out? Oh, no, you're cutting out. Oh, sorry. I guess there's been some acrimony in the chat tonight. Let's keep it civil, guys. Let's all get along. We're here to enjoy the experience of seeing Asteroid Apophis, right? So, yeah, sorry. Getting back to the original question I was answering from Joseph, bottom line is probably not the same guide star, but also probably doesn't matter, because the Paramount isn't using an adaptive optics unit, so it doesn't benefit from guiding at insane rates like this. You only get that benefit if you have a tilt-tip mirror that can respond instantly to any corrections that are being made. The motors of the telescope, even with a high-quality Paramount, are not going to be responsive enough that guiding at 16 Hertz is going to make a noticeable difference compared to guiding it, twice a second or something like that. But with this system, it does make a difference, and it does make the stars a bit sharper. Yeah, thanks, Andrew. I probably need to look at appointing more sheriffs. Andrew, you're doing a good job, but sometimes the crowd can be a handful. I feel bad that you're all in there on your own there, Andrew, having to moderate by yourself tonight. Sorry about that. Could a coronal mass ejection alter the course of the asteroid? Well, not really. Solar radiation pressure over time will alter the course of the asteroid, but we're talking a very minute effect that takes years to produce a noticeable impact. If the asteroid were much lower density, if it were, say, if it had a broad surface area and a low density like a solar sail, then yeah, solar radiation pressure has a more immediate impact. Even artificial objects in space, like rocket stages, spent upper stages of rockets, things like that, tend to be a lot less dense than asteroids. And so small effects like solar radiation pressure tend to have more rapid impacts on their orbits, and they tend to reveal themselves that way. 2020 SO was a perfect example of that. Over the short course of time that it was in an unstable Earth orbit, that orbit was impacted more by solar radiation pressure than your typical asteroid would have been. So you could tell it was a lower density object, which was consistent with it being a Centaur upper stage. But a rock like this, a really big, heavy rock like this, doesn't have, a coronal mass ejection is not going to have a real influence on us. A single event like that's not going to have a real noticeable influence on it. And over time, the sun's light and the radiation will impact the trajectory a bit. You get other effects like the Apophis effect. So how it's throwing off photons as the asteroid is spinning, and its shape and all of that can have impacts on the trajectory. But again, these things take years to manifest. However, when you're looking at impact possibilities that are decades out, then yes, it does become an important variable. And that's one of the big problems with trying to determine whether this asteroid does have any chance of hitting us in the future. We're talking 2050s, 2060s. At those kinds of time points, that far out, decades into the future, you do have to have a good understanding of things like the asteroid's shape, its reflectivity, and how solar radiation pressure is going to influence it over time. And so it takes, years of tracking to be able to see what those variables are, to see essentially how to fit the determination of those variables to the data. What combination of factors would produce the data that we see in terms of how it's actually moving over years of time. Again, this asteroid was discovered back in 2004. So there's now been just about 17 years of tracking on it. And so at that point, you're able to start making some determination of some of these variables, these long-term impacts on the orbit, and how they seem to be influencing the asteroid over time. Of course, we also have radar observations of the asteroid. Unfortunately, of course, Arecibo recently collapsed, and that was a real problem, a real detriment to astronomy. Because although there are other radio telescopes out there, not all of them are capable of the kind of radar imaging of asteroids that Arecibo was capable of. A lot of people pointed to this big radio dish in China that was bigger than Arecibo, is bigger than Arecibo was. But it doesn't, my understanding is it doesn't have the active systems that Arecibo had for sending out a radio signal and bouncing it off an asteroid. It didn't have the radar capabilities of Arecibo. So although it is superior perhaps at passive observations, it is not capable of the active observations, the actively sending out a radio signal to bounce off the asteroid, to measure its shape, to actually see what the shape of that asteroid is as it flies by. And so, if Arecibo were still around today, I suspect it would likely have been used to observe this asteroid this weekend during its close approach to Earth this year, ahead of the 2029 apparition. And of course, I'm sure it would have been used in 2029 too. But that's unfortunately, that's no longer possible. Hopefully, something can come and be constructed in its place and restore those capabilities, because that was important not only for astronomy, as a science, but for planetary defense, for understanding the shapes of these asteroids and getting a better idea of, for example, what asteroids make a good target to send missions to, and how their orbits will evolve over longer periods of time due to things like the Apophis effect. So the streak near the cursor is Apophis. Andrew says there's plans to build a better telescope. Yeah, I hope that comes true. I hope that comes to fruition, and that it's capable of the kind of radar observations in particular that Arecibo was always best at. Because that was a real significant part of its legacy in my mind. Have I ever considered switching to different software for imaging? I probably should. I really haven't given that much serious thought. CCD Soft, to call it long in the tooth, is laughably understated. It's not designed for Windows 10. It's not actively supported anymore. It's not the best way to go about things. So, yeah, I probably should look at modernizing my software setup for image capture. I just don't have experience using other options. I mean, I guess I had some degree of familiarity. I wouldn't even call it that, but I've encountered Maxim DL. I've tinkered with that a little bit. I would not call myself all that experienced with it, but I have had a little bit of experience with Maxim DL. Don't currently have a copy of Maxim. I don't even know if that is like what people are using these days. I don't know what people are using these days. I'm still stuck back here in the 90s with my CCD Soft. But I guess if I'm going to switch software packages for image capture, obviously it's got to support my camera. It's also got to support the adaptive optics unit, the AO7, and hopefully all of that is relatively streamlined and accessible. I like being able to manually tweak the calibration of the drive and the AO7. I like certain things about CCD Soft. I just wish it weren't so broken. So, yeah, I guess that's a long way of saying I guess I would be open to it. I just haven't spent the time to really look into it and see what other options might fit the bill for me. But whatever I pick, it would have to be compatible with this hardware. I like this hardware. I don't really want to change it. Yes, there's more modern cameras out there. There's better cameras out there. But for this setup with the LX200, it's going to need an AO system. There are other alternative AO systems available, but that's expensive. Replacing the camera, very expensive. So I'd like to keep the hardware I've got. Heck, I've got two of these cameras. I love them so much. I got another ST2000 sitting in the closet right now, ready to go at a moment's notice if this one ever gives up the ghost. Knock on wood, it won't do that anytime soon. Plenty of modern open source, yeah. Andrew, you gave me like PTSD there, man. Thinking, oh man, am I gonna have to like tinker with something open source, make it work with this hardware, make it work with the drivers I've got for this hardware? Hopefully there's something out there that is ready to go, plug and play off the shelf, and I'm sure there is. You use K-Stars, interesting. PhD 2? I didn't know PhD 2 supports AO. Oh, for guiding purposes, I guess. Yeah, I mean, I guess I could go that route. I have experience with PhD 1. I used to use PhD all the time, back when I was using webcam-style imagers as auto-guiders, that kind of thing. Even the Attic Titan C. I've got an Attic Titan C laying around that serves as a good auto-guider in some cases. but I didn't. I wouldn't want. Ideally, I would want the camera and the AO to all fall under the same umbrella, under the same program. I guess I could split it up and use 2 programs for the 2 jobs, one for guiding, one for imaging. But I really would prefer to have it as an all-in-one package if possible, like what I've got here with CCD Soft, where it's just all in the same window. But you've piqued my curiosity there. I am curious, like, how well PhD 2 would work with the AO. I mean, does it get the same, guide rate pound for pound, or is there any additional latency in there? These are the questions I have. And, how well does it handle bumping the telescope to keep it in the range of the tilt-tip mirror limits? Because, I mean, CCD Soft does handle that pretty well. And I'd like that to continue to be the case. Yeah, just roll my own software, use Python and OpenCV. I mean, I could, but I just don't know that I'd be able to get the kind of speed that you can get out of this. I mean, we're guiding at 16 hertz here with 0.03 imaging, so what are we looking at? 30-something exposures can fit in that. Yeah, maybe. I wonder about the speed of Python. Python's nice. Python is very powerful, but it's not always the fastest option. I mean, it really isn't. You probably want C or C++ or something for this kind of application where you really want instantaneous processing. You really want speed because you're guiding it, 16 times a second. Could it be done with OpenCV? Thinking maybe. But then you gotta roll your own. You gotta interface with the drivers. You gotta do a bunch of stuff. That's just a pain. And then you gotta you gotta guide in the you gotta code in the image calibration, the camera calibration, the mount. Yeah, that's a whole headache there. I don't have time for right now. One day when I'm retired and I've got nothing but time on my hands, I'll do that. Do 30 frames per second on a Pi Zero. Yeah. I mean, it's a pretty simple brightness tracking operation, right? It's not like you're doing some sort of facial detection or object detection or anything like that. You're just looking at a brightness value, trying to do centroiding of the star. It's a pretty simple operation mathematically, so at least that part's easy, I guess. Good night, Tristan. Are you referring to the dev of PhD 2? Oh, compute module Pi 3 does it with one ARM core. Yeah, all built in. Yeah. I mean, that's fair enough. Like the image tracking of the star, that's easy to do. Easy peasy. The real issue is feeding that into the scope. You've got to manage the tilt-tip mirror system. You've got to manage keeping that within the boundary of that with the scope in a sensible fashion. I mean, it's all doable, but I really don't like the idea of having to code up my own drivers or somehow tie into the existing libraries. I don't know. That's just it's a headache. It's just time. I just can think of other pursuits that I have an interest in doing right now, coding wise. and rolling my own image capture software for interfacing with my cameras, it's just not a high priority. I mean, CCD soft, yeah, it's a little janky, sometimes it's a little broken, but it works, mostly. It mostly works. As long as I treat it right and work around its quirks, I can make it work. So that really inspires me to be lazy about it and not replace it. But if there were an off-the-shelf solution that worked as well as CCD soft without the bugs, yeah, I'd go for it. And in the long term, then yeah, maybe I would code something myself, but yeah, that's... I just feel like, okay, a couple things. One is the time factor. The other is the novelty factor. I mean, it just feels like that's something that should already exist in the marketplace. There should be, and there probably is, a good solution out there, an all-in-one solution out there, like a Maxim DL or something like that. It'd be like me trying to roll my own word processor. Why would I do that? There's perfectly suitable options out there, open source and otherwise, right? And I'm sure there's open source solutions here too. It's a whole bundle of fun that I haven't got into yet. But for anyone who's interested, if you join as a channel member, you'll get access to my existing software like Sat Tracker and Rocket Tracker. Those are the two programs I've released so far to channel members, and more will be coming along with updates. So you can unsubscribe from unjoin at any time. I don't know what they call that, but you can, stop your channel membership at any time. You'll continue to, you can continue to use the programs. They don't time out. The executables will be ready to go for you at any given time. It's just updates will be coming for channel members with new features and things like that. Oh, I didn't see the link. I don't know why it didn't show. I don't even see it like as a link that's waiting to be approved or anything. It's strange. Yeah, Andrew, you've got some expertise. You actually do this stuff for professional. Yeah, if you got an old refractor, you should definitely dust it off and give it a go. I mean, this object is kind of dim. You're probably not going to see Apophis with your refractor. We're talking about magnitude 15 plus here. Sky Safari says magnitude 15.6 tonight, and that's on par roughly with the central star in the Ring Nebula. And back when I had my 6-inch Newtonian, I remember seeing the Ring Nebula, but I never spotted the central star even with a 6-inch. I was never able to quite peg the central star in the Ring Nebula. Oh, thanks. Yeah, consider joining. I mean, it's not necessarily going to be useful for everybody. Rocket Tracker right now is only designed to work with ASCOM-compatible scopes that have the move axis method enabled, and it's only been tested, really, on Next-Star telescopes. There's still more testing to do, more bugs to squash, but that's what the updates will be for. Sat Tracker, I've got more testing completed on that, of course. That is designed to be compatible with both the AUX 200 Classic and ASCOM compatible scopes, as mentioned before. and I've got some, pretty good footage with Sat Tracker of the space station, Hubble, and even some Starlink satellites. Oh, Barlow's aren't going to help you. That'll just amp up the magnification, but really that's not going to help you with the biggest problem, which is aperture and light collecting area for an object this size. You really need, even with this scope here, I probably wouldn't see it in the eyepiece by eye. You really need this CCD for the sensitivity to be able to pick it up like this. But it's worth the, dusting off just for the sake of doing astronomy with it. Just don't get disappointed if you're not able to find Apophis. And an update to the last Deep Space webcast I did, we talked a bit about the EV scope and Unistellar and some of these off-the-shelf astrophotography rigs that they sell that are intended for beginners because they're totally automated, but they also are not really upgradable. It's not like you can just pop the camera out and swap it out easily. And the apertures on these things are quite small, and yet they're $3,000 telescopes. They're very expensive for what you're getting, in my opinion. And they had articles about how Apophis was going to be occulting a star a couple weeks ago, and you had to be in a very narrow corridor to see it. Unfortunately, it passed south of my location. I would have had to be in the Gulf of Mexico to be able to see it, but they were talking about being able to see Apophis that way by seeing a star blink out as the asteroid actually passes in front of it for a fraction of a second. But I have seen at least one image from what reported to be, I believe, an EV scope of Apophis, and it's very, very faintly visible as a streak. So, yes, that $3,000 telescope can see it this weekend. However, to be honest, it did not look nearly as good as what you're seeing right now. It was a very faint streak. I had to look twice to see. I had to kind of glance at it, and I'm like, wait, what? Oh, let me look a little closer. Oh, there it is. There it is. Very, very faint streak in the EV scope. So I'm not particularly impressed by that, to be honest. For $3,000, you could have bought this rig here, at least on the used market, camera, telescope, and all, and had much better pictures of Apophis. Does Sat Tracker use a camera to update the position and keep the satellite in the center? Yes, that is the whole purpose of Sat Tracker, pretty much. I need to do another tutorial video on some of these programs. That'll be the next thing on my hit list here after I do this Apophis video. But yes, that's the magic sauce of Sat Tracker. You use a viewfinder camera. It doesn't have to be particularly high focal length, doesn't have to be particularly fancy. Even just a standard def camera will do just fine, believe it or not, with a security camera lens on it. I mean, we're talking very short focal lengths here, pretty wide angles of view, but it uses that to lock on to the satellite based on its brightness and keeps it centered in the view. So that way you can track things like the space station even at high magnification and keep it in the view. So it's worked quite well for me so far, and I've been able to get some pretty good footage with it. So I intend to do another video going over that and really showing how that process works. Yes, can you set an offset in case you're using an OEG? Yeah, I mean you can set the crosshairs, as it were. It's not really crosshair. It's more like just a red box. But you can set the box that indicates the center of the viewfinder wherever you want it in the image. So even if you're off axis a bit, that's not really an issue. You can what you do is you co-align it. Of course, you point it at a known star or something in the distance, and then you click you set center point. You click set center point in the program and click where that star or object appears in the viewfinder camera. And you can also use the arrow keys to move the it's a little hidden feature, I guess. You can use the arrow keys on your keyboard to move the center point of the viewfinder camera 1 pixel in each direction. You can bump it that way and co-align it very carefully. And then you're off and going. You load in your TLE file of the orbital elements of the satellite. You need to know when the satellite pass is going to be. At the moment, it doesn't tell you. That's another creature comfort I need to add in there. So it's not really intended as a program that you use to predict when the pass is going to occur. You can use other software for that, but for the moment, you just need to know, okay, this is the time the satellite is rising, and then you can click Start Tracking, and it'll send the telescope there and start tracking it. Then you just click in the viewfinder camera. When you see it, you just click on it and lock onto it. Yeah, hand tracking ISS is not easy at all. Debris field? No, these are stars. Apophis is this little streak right here, and then there's a bunch of other stars around it. Alright. So I was just checking the scope in New Mexico. There's 2 more exposures coming in from New Mexico. Using itelescope.net to capture some simultaneous observations and be able to get some parallax data to help nail down the distance of the asteroid and help refine the orbit. In fact, I'm not sure how much parallax there's going to be. If it's small enough, which it probably is, I may be able to make like some sort of stereo image of the asteroid. Now, the New Mexico scope's not shooting color images. This camera here that I'm using, that you're seeing, uses the KAI 2020 CM CCD, the same type of CCD that's in the mast C cam of Perseverance, the Perseverance rover. And it's also found in the mast cam of the Curiosity rover. It's a single-shot color camera, but the scope in New Mexico is using a grayscale imager. So those will not be color images, and of course they'll have a different resolution and image scale and all of that. But if I line them up, maybe line the videos together, it'd be kind of cool to make like a red-blue 3D image or something of the asteroid flying in front of the stars. I don't know, just a passing thought I had. Something went a little wonky with the tracking on that image. I can tell the difference anyway. Not sure what that was all about. Have I ever considered a monocam? I mean, I have, but to be honest, having single-shot color capability works out in my favor for doing live streams like this. Yeah, there's a price to be paid for that in terms of the quality of the image data, but for my purposes, at least, for doing live streams and such, I think it makes more sense to do it this way with color image data. Let's see how this image comes out. Hopefully better than that last one. I've been sort of trying to keep an eye on the guide star. It looks okay. So if it's looking funky, it's probably camera rotation from not being locked down tight enough. I hope that's not the case. Well, that one came out good. That's a relief. Alright, I'm going to see if I can process the images done so far into a quick and dirty time-lapse to show on the end of the stream here. So for those of you who've hung on till the end, we're going to be wrapping up here in a few minutes. It's midnight now here in Florida. So I'm going to be wrapping up the stream here shortly. But I want to thank you all for coming. And for those of you who've hung around to the end, hang on for just a few more minutes, and I will do a quick and dirty process with a special program I've written for doing sort of instant time-lapse processing of these images. So stand by for that. So I know the image has gone out. Sorry, that's deliberate for a second here. I've had a little issue with the files not auto-copying over my network as they were supposed to, so I've had to pop on a USB stick to pull them off. And now I return you to the last image received of Apophis. I've shut down the imaging for now. We're going to be wrapping up here shortly, but let me go process these real quick and show you guys the time-lapse. Okay, so for those of you who've stuck around to the very end, I finally have it. Let's take a look at the final product. So here is, as soon as it comes up, the time-lapse of the frames captured tonight. Here you go. Apophis in motion over the course of tonight's webcast. So now I'm just going to take some flat fields for image calibration offline and work on that. And then later work on the astrometry, measuring the coordinates of Apophis over the course of the webcast in order to measure the orbit and actually determine the orbit. And then that will go into another video later on with the time-lapse of the images from tonight and from a couple weeks ago as well. So stay tuned for that. Thanks everybody for watching. Hope you enjoyed it. And see you all next time. Till then, clear skies, folks.